Hey everyone, welcome back to Leet Code Unlocked. Today's GFG problem of the day is a natural follow-up to yesterday's sliding window problem. Yesterday we solved longest subarray with at most two distinct integers, where we had to find the max length. Today, we're going a step further. Count all subarrays that contain at most k distinct integers. Let's dive in. Given an array R and an integer k, return the total number of subarrays that contain at most k distinct integers. This is a generalized version of yesterday's problem. Instead of just tracking the max length of a subarray with two distinct elements, we now count all such subarrays for any value of k. So instead of finding the longest window, we're summing up window lengths, a subtle but powerful shift. We use the sliding window technique again, 2 pointers I and j and a HashMap to track the frequencies of elements inside the window. Here's the key change. Every time the window is valid, i.e. has less than k distinct numbers, we count all subarrays that end at j and start from I to j. That's exactly j minus I plus 1 subarrays. Let's walk through the code that counts subarrays with at most k distinct integers. We use 2 pointers I and j to define the window boundaries and a HashMap to store the frequency of elements within the current window. As we move the right pointer j, we include the current element in the window by increasing its frequency in the map. If at any point the number of distinct elements exceeds k, we shrink the window from the left by moving pointer I forward, and also reduce the frequency of that element in the map. If the frequency drops to 0, we erase it from the map. Once we have a valid window, that is, one with at most k distinct integers, we add j minus I plus 1 to our count. Why that expression? Because all subarrays ending at position j and starting anywhere from I to j are valid. So for every valid window, we're counting how many subarrays it contributes. Finally, we return the total count. Let's dry run the sliding window logic using the input array 1, 2, 1, 2, 3 with k equals 2. We'll walk through each step using 2 pointers, I and j, a frequency map, and a count variable. Step 1. J equals 0. We include the element 1. The map becomes 1 is equal 1. That's only one distinct element, which is valid. We add j minus I plus 1 equals 1 to our count. Total count is now 1. Step 2. J equals 1. We include 2. Map is 1, 1, 2, 1. Now we have two distinct elements, still valid. We add two subarrays ending at j equals 1. Total equals 3. Step 3. J equals 2. Element is 1. We now have 1, 2, 2, 1. Still just two distinct. We add j minus I plus 1 equals 3. Total equals 6. Step 4. J equals 3. Element is 2. Map is 1, 2, 2, 2. Still valid. Add 4 subarrays. Total equals 10, ... Step 5. J equals 4. Element is 3. Now the map becomes 1, 2, 2, 2, 3, 1. 3 distinct, so we shrink the window. Move I to 1, 1, 1, 2, 2, 3, 1. Move I to 2, 1, 1, 2, 1, 3, 1. Move I to 3, 2, 1, 3, 1. Finally valid again. Now we add j minus I plus 1 equals 2 more subarrays. Final total equals 12. By sliding the window and counting all valid subarrays ending at each position, we find that the total number of subarrays with at most two distinct integers is 12. Time on. Each element is visited at most twice. Space OK. HashMap holds at most k keys. And that's how we count subarrays with at most k distinct integers, a clean extension of yesterday's problem that uses the same sliding window strategy, but with a twist in the count logic. If you understood the difference between longest subarray and count of subarrays, you've just unlocked another powerful DSA pattern. Like the video if this helped, and subscribe for daily breakdowns of GFG, LeetCode, and NeetCode Pre.